Hello students, I am Pawan Kadgavkar, lecturer in Information Technology, Government Polytechnic Amravati. Today we are going to cover the topic that is transaction processing in the database management system. Let's see what is the learning outcome of this particular point. You are going to learn the importance of the transaction. After that you are going to understand what is mean by deadlock, how to handle that deadlock, how to prevent your database to be in a deadlock, to become in a deadlock, and how to recover your database from the deadlock itself. First, that is deadlock. So what is deadlock? You may have already seen this particular concept in the operating system. In the database, the deadlock is a state of database actually, where the two or more transactions, when each transaction is waiting for a data item that is being locked by some other transaction. Means that if there are multiple transactions are there, and out of which that some transactions are waiting for same data item, at that place the deadlock in the database system is going to be occurred. Let's see one example, that if you take an example of a banking where we are transferring amount from account A to account B in a transaction T1, okay, and another transaction T2 wants to update the same data item which is held by transaction T1. At that time the deadlock is going to be occurred in this particular transaction over there. How to handle the deadlock? Okay, let's consider one example. Following, there are two transactions are there, T1 and T2, where in the transaction T1 we are going to write the value of data item X first, and after that we are going to write the value of data item Y. Whereas in the transaction T2 we are going to write the value of data item Y first, and after that we are going to write the value of data item X. Let's try to understand how to handle these deadlocks, or how that deadlock is going to be occurred with the help of some schedules over there. Schedules in the database are the sequence of transactions that are executed. In this particular schedule, first the transaction T1 is going to be executed. In this particular transaction T1, the lock on X data item is going to be obtained first of all, and the value of data item X is going to be written in the database. After that the transaction T2 is going to be executed. Here in the transaction T2, lock on data item Y is going to be obtained first of all, and after that the value of data item X is going to be written in the transaction T2. And after writing the value of X, the transaction is trying to get a lock on X. Transaction T2 is try to get a lock on X itself, but it is not possible for a transaction T2 to obtain a lock on X, because the data item X is already locked by transaction T1. So the transaction T2 has to wait for a data item X till the transaction T1 does not release lock on data item X. Now after that, in the transaction T1, the transaction T1 try to obtain a lock on data item Y, but it is not possible for a transaction T1 to obtain a lock on data item Y, because the data item Y is already locked by transaction T2. So the transaction T1 has to wait to get a lock on data item Y till the transaction T2 does not going to release the lock on data item Y. This is how the deadlock is going to be occurred in the database system. Let's see how to prevent your database from occurring a deadlock over there. Deadlock prevention protocol ensures that the system will never into the deadlock. There are some protocols, or the rules we can call it as which ensures that the system will be deadlock free. So let's see what are these different rules over there. Some prevention strategies are there. require that each transaction locks all its data items before it begins execution. That is the first rule. If you don't want a deadlock in your database, in that condition you have to lock all your data items before you start your transaction, so you will be not in a deadlock. After that, another rule is that imports partial ordering of all data items and require that a transaction can lock data items only in the order specified by the partial order. So before you go to start for a transaction, in that condition you have to obtain a partial ordering of all data items which you required in your transaction. So it is possible for you to use all all data items which you required if you order that all data items. There are some ways to prevent your data items prevent your database to be in a deadlock. Okay, first scheme is that wait die scheme, non-preemptive scheme. It is a non-preemptive scheme. In this particular scheme, the older transaction may wait for a younger one to release data items. Means that those transactions, those who are older one, they may wait for the newest transaction or the youngest transaction to release the lock over here. Younger transaction never wait for older ones, they are rolled back instead. So the newest transactions are never going to be wait in this particular scheme, they are going to be rolled back instead. A transaction may die several times before acquiring needed items. It may be the possible that particular transaction may have to roll back multiple times till it will not able to get or will not able to obtain a lock on a particular data item. Second scheme is that wound wait scheme, preemptive scheme. Older transaction wounds of younger transaction instead of waiting for it. Younger transaction may wait for older ones. Here in this particular scheme, it is exactly opposite of your wait die scheme. Older transactions rolled back for of younger transaction instead of waiting for it. Maybe fewer rollbacks than wait die scheme. It may be possible that because here the older transactions are going to be rolled back rather than waiting for the younger one. So it is possible that there may be the less number of rollbacks in this particular wound wait scheme. Another scheme is the timeout based scheme. In this particular timeout based scheme, a transaction waits for a lock only for a specified amount of time. Here, every transaction allotted with a specified amount of a time so that the transaction will obtain a lock on a particular data item for that particular time only. Once that time is finished, automatically the lock on that particular data item is going to be released over there. So there are very less possibility of deadlocks in this particular timeout based scheme. It is also simple to implement, but the starvation is possible. In this particular timeout based scheme, the starvation is possible. Starvation means a same transaction is going to be rolled back again and again. This is the meaning of starvation over here. That is the disadvantage, we can say it as. Let's see how to detect deadlock. We are going to detect deadlock with the help of graph, wait for graph. Here we are going to mention V is a set of vertices, all the transactions in the system, whereas E is a set of edges. Each element is an ordered pair from transaction Ti to Tj. Here we are going to detect deadlock with the help of wait for graph. In this particular graph, we are going to mention vertices V as a all transactions which are going to be happen in the database, whereas E is a set of edges from a particular transaction to another transaction. If transaction Ti to Tj is in E, then there is a directed edge from Ti to Tj, implying that Ti is waiting for Tj to release a data item. If we have a edge from transaction Ti to Tj, the meaning of it is that transaction Ti is waiting for transaction Tj to release a lock on particular data item. When Ti requests a data item currently being held by Tj, then the edge Tj is inserted in the wait for graph. Let's say that the transaction Ti wants a data item which is held by Tj at that time, and it is continuously requesting for the data item which is held by Tj. In that case, we are going to insert a edge in the graph from transaction Ti to Tj. This edge is removed only when Tj is no longer holding a data item needed by Ti. This particular edge is going to be removed only if the Ti will get a lock on a data item which is held by transaction Tj. The system is in a deadlock state if and only if the wait for graph has a cycle. We can conclude or we can detect a deadlock in a database only if we say that there is a cycle in a wait for graph. Let's see with the help of one example that over here there are two graphs here, that is wait for graph without cycle and wait for graph with cycle. We can say that the database in a deadlock if there is a cycle in this particular wait for graph. Here the wait for graph without cycle T25, T26, T28 and T27, there are 4 transactions are there. Each one is waiting for a data item obtained for its previous transaction, but there is no cycle in this particular graph. Here the T26 is waiting for T25 to release data item, the T28 is waiting for a data item which is held by T26, the T26 is waiting for a data item to be released by T27, the T25 is waiting for data item which is held by T27, but there is no cycle over here, so there is no deadlock in this particular database. But if we will see another example, that wait for graph with cycle, that here the transaction from transaction T25 to T28, everything is waiting for data item, but here that transaction T27 is waiting for a data item which is held by transaction T28, which completes a cycle over here. So we can say it as this particular database is in a deadlock. Till now we are well aware about what is mean by database deadlock. Now we are going to learn how to recover your database from this particular deadlock. There are some ways, or there are some points with the help of which we will be able to recover our database from the deadlock. Some transactions will have to roll back to break deadlock. The main or the important thing in the database is that whenever you see your database in a deadlock, at that time you have to roll back some transaction over there. At the time of rolling back your transaction, you have to consider the minimum cost of that particular transaction. Cost in terms of time, in terms of space required in database, in terms of the length of that transactions. So you need to consider this particular points at the time of rolling back your transaction. You can roll back the transaction in two ways. Either you roll back your complete transaction, or you have to roll back that transaction in a partial way. When you roll back your transaction completely, at that time you have to end your transactions and restart your transaction again. Another way to roll back transaction is the partial one. up to the extent where deadlock is going to be break. At that point only you have to roll back your transaction. You don't need to roll back your complete transaction over there. In this particular rules, there may be the possibility of a transaction starvation in the database. So you have to take care that you are not going to roll back a same transaction again and again to avoid starvation in the database itself. So in this way, with the help of rolling back some transactions, you can be able to recover your database from the deadlock itself. That's it. These particular points we have covered in this particular unit, that are the you learn what is meaning of deadlock, how to handle that deadlock, how to detect the deadlock with the help of some graphs, vertices and edges. Then you learned how to prevent your deadlock with the help of wait and die scheme, wait for graph scheme. After that, you learn the deadlock recovery, how to recover these deadlocks, database deadlocks, with the help of rolling back some transactions. I hope you understand all the terms related to deadlock. Thank you and happy learning. Thanks.